All right, one of the big things with arc welding, because it's not just squeeze the trigger and go, is jig and fixturing. It's huge with arc welding. And that's why a lot of shops aren't using arc welding anymore. It's kind of an old welding technology. The welding itself is still very good, but if we take a look at this, we'll show that it's very important to have this set up. I'm using a magnetic triangle right here to keep this at a 90 degree. And what I have to be very careful of here is when I start my arc weld, when I bring this in, I have to scratch out here, bring it over right away once I have the arc, and then start welding. Because I don't want to bump this. If I bump it, then I'm going to weld it incorrectly. Now, I don't care where this is right now because it's just practice, but let's just say that's right where I want it. And if, well, you'll see here, it gets, it's just a little bit more setup, a little bit more things to worry about. So here I am. I'm going to try and strike my arc and bring it right back to there, and then I'm going to stop and do another tack right there to hold it. Ready? Yeah. Other tack. Now if we're looking at that, those look like really bad welds for MIG welding. But when we chisel away, when I let these cool now and I tap that slag and bust that stuff off, we'll probably see a really nice weld in there. They're still too hot. But a tack weld doesn't need to be pretty, and then we'll re-weld all right over that, and it'll be real nice. I'm gonna switch to the 7014. I know off the bat that 6011s are set up for max penetration, and they spatter a lot. So we can go back and take a look at the actual weld spatter, but let's just see what happens when we switch to the 7014. I'm going to stop halfway. My experience is telling me that my amperage is set a little bit too low for this. So I'm going to turn it from 75 up to 90. 95. 75 to 95 just to see how that turns out. Might be able to hear a little bit different and notice that it's stuck a couple times. I think that'll alleviate some of that because we're giving it more power, which means I can increase my arc distance a little bit and still keep welding.
You can see I'm about a 1/16 of an inch away further from the metal. Going over that tack weld
and finishing it off. Now we're going to have to let that cool, and if you can pan over, you can see that it's still a little bit orange and it's cooling off now. This stuff holds its heat pretty well. This acts like insulation on there. So you really got to be careful with this stuff. This might have to cool for like 30 seconds before I chip that stuff away. It's dirty, there's sparks a lot everywhere. It's just a little bit more crude of a type of welding. It's very good, it's not any weaker, and sometimes it actually gives you a little bit more control, but it's just kind of a lost, not lost technology, but it's fading because MIG welding is so touch and go and easy. So let's try it, see if it's cooled off enough. Now I'm going to use the wire brush. Let's zoom in here. Shut the power off on the welder. These turned out okay. We can tell right now that there's still some slag down here. Still some right in here in this pocket. So sandblasting might actually be a good alternative to get rid of some of this stuff here. But you can see here is about halfway, and the 7014 welded more onto the base metal And if we got rid of this, we could probably see that it's touching on here. And then when we look back over here, we can see that we're getting more onto the bottom metal. So by having that amperage turned up, it was definitely a good switch. So what I'd like you to do for your assignment is to just do a series of beads on here, probably 3 beads, 3 inches long, just to get some exposure to this. And then we'll go from there. We might have a second assignment, but just kind of an exposure to arc welding.